Welcome to today's deep dive. And, if you're joining us, you're probably the kind of person who really wants those aha moment.
Oh, for sure. You want to know how things actually work under the hood?
Exactly,
Yep.
without
Mhm.
like completely drowning in technical manuals. And today we are unpacking something that has this universal reputation for just being incredibly stressful.
Yeah.
I mean, we're talking about building a custom home,
Yeah, it's notoriously a headache. Everyone has a horror story.
right? But we're looking at this really fascinating article from Simpson and Co. Projects, and they have a thesis that completely flips the script on why it's so stressful. They argue that the stress doesn't actually come from the physical construction.
No, it's not the bricks or, the unpredictable weather or pouring the concrete.
Yeah.
It's actually, the stress comes entirely from a fragmented process. It's a lack of systemized communication.
Which is wild to think about. So
Mm.
that is our mission today. We are going to explore exactly why these custom builds unravel, uh, the hidden danger of working in silos, and how the right process creates like absolute clarity and control.
Right. And to understand the fix, you sort of have to look at the root of the problem first.
Okay, let's get into it. Because most people assume the traditional way a house is built is, the right way or the most efficient way. You hire an architect, they draw the house, and then you just hand those drawings to a builder to build it. It's this very linear timeline.
Yeah, but that linear timeline is exactly the core of the issue. It creates this highly disconnected environment.
Also,
Well, think about it. A client decides they want to build. They hire an architect, and they spend months, sometimes years, refining this vision in total isolation.
just the two of them.
Just the two of them. The architect is focusing on, spatial relationships, catching the natural light, council zoning, and obviously hitting the client's aesthetic dream, but they're doing this without a builder in the room.
Okay, I want to unpack this because it's like writing a blockbuster sci-fi movie script, right?
Hmm.
You write in these floating cities and zero-gravity battles and crazy alien landscape.
Yeah, that looks amazing on paper.
Right. But you do all of that without ever consulting the special effects team until the literal morning you start filming. You just hand them the script and say, okay, build this.
And the special effects team looks at it and goes, the laws of physics and our budget do not actually allow for this.
Exactly.
And that translates perfectly to construction. We call it buildability. When an architect designs without a builder's immediate input on practical buildability or live market costs, you get these severe blind spots.
So wait, give me an example. What does a blind spot look like?
Okay, so an architect might design a stunning minimalist floating staircase. Beautiful, right? But the builder, looking at that design later, has to figure out the actual structural steel required to hold it inside the wall.
Oh, wow.
Yeah, and they have to figure out the sequence of trades to install it without shattering the custom glass. And this is huge, the current supply chain lead times for those specific materials.
But wait, I mean, if an architect designs houses for a living, shouldn't they just inherently know what things cost and how they go together? Why are they operating in a silo in the first place?
It comes down to the division of expertise, really, and how the industry historically structures contracts. I mean, architects are experts in design and compliance. Builders are experts in execution and live market economics.
I see.
Because material prices fluctuate monthly, labor shortages happen dynamically, an architect just cannot accurately predict the live, on-the-ground cost of a complex structural framing sequence like a year before construction even starts.
That makes total sense. So when the design happens in a silo, without that real-time feedback loop from the builder, you end up with plans that exceed the financial boundaries.
Exactly. Or they have structural complexities that are just a complete nightmare to execute on site.
I can really see where the emotional toll kicks in for the client here. Think about your position in that flow. By the time you finally bring the builder in and ask, hey, how much will this actually cost? You're already deeply invested.
Emotionally and financially.
Yeah, you've already pictured your family living in that specific space.
And then the builder has to deliver the reality check. They look at the plans and say, this is financially out of reach, or this is structurally unrealistic to build as drawn.
Oh man, that is brutal.
It is. So before a shovel even hits the dirt, you're forced into making immediate, painful compromises. You have to scale back this dream you just spent months perfecting. That is where the stress begins, long before the actual construction phase.
Okay, so if the linear model is broken because it separates the vision from the execution, here's where it gets really interesting. What happens when those isolated designs actually hit the dirt? like out on the active construction site.
This is where we run into the trap of assumptions. So in theory, a builder receives what the industry calls detailed documentation.
Detailed documentation, got it.
Yeah. Detailed documentation is the comprehensive set of architectural drawings, structural engineering plans, the schedules used for quoting. It's supposed to be the master blueprint where every single detail is perfectly resolved.
I'm guessing in theory is doing a lot of heavy lifting in that sentence.
Oh, it is doing all the heavy lifting. Because when that traditional fragmented process is used, that detailed documentation almost always has gaps.
What kind of gaps?
Things like specific material selections or intricate structural interfaces between different materials. Exact trade sequences are just left as assumptions on the plans. The mindset during design is often, oh, we'll figure that exact detail out later when we get to it.
We'll cross that bridge when we come to it, which, sounds totally reasonable when you're sitting in a quiet office looking at paper. But I imagine it plays out very differently when you're standing in the mud with a crew of tradespeople just waiting for instructions.
Night and day difference. And that discrepancy introduces a really critical term from the glossary that we need to understand: the prime cost item, or PC item.
Prime cost item. Okay, what is that?
A PC item is a financial allowance in the contract for an item that hasn't been specifically selected yet when you sign the contract. It acts as a placeholder.
Oh, okay. So a PC item is essentially a financial ring fence. Like, you haven't picked the exact oven or the exact tiles yet, but you've allocated a budget for a standard version so the whole project can keep moving.
That's the intention, yeah. But leaving those selections unresolved creates massive vulnerabilities on site. Let's look at a really specific scenario to illustrate this. Let's talk about the bathtub domino effect.
Oh, I love this example. Let's walk through it, because on the surface, changing a bathtub sounds like literally the most trivial decision in the world.
It really does.
So let's just say I'm the client. I'm looking at my plans. I have a prime cost allowance for just a standard off-the-shelf acrylic bathtub. But mid-build, I'm scrolling through design blogs, and I find the tub of my dreams, a custom imported solid stone designer bathtub.
Right.
I think to myself, it's my house, I'm paying for it.
Yeah.
Just swap the standard tub for the designer tub. No big deal, right?
Right, because on paper, it's just crossing out one word and writing another. But on the site, swapping that standard tub for that imported designer tub triggers just a cascade of physical and administrative consequences for the builder.
Walk me through the physical reality first.
Okay, first, that custom stone tub is immensely heavier, and it likely has a completely different physical footprint than the standard acrylic tub the engineers initially planned for.
Because it's a solid block of stone holding hundreds of liters of water rather than just a lightweight plastic shell.
Exactly. And that crazy density immediately alters what is known as the load path.
The load path.
Yes, the load path is the specific route through which structural forces travel. So the weight of the tub pushes down on the floor joists, which transfer the load to the structural beams, which carry it to the columns, and all the way down into the foundations.
Okay, I follow.
The original floor joists in your house were engineered specifically for the distributed weight of a standard light tub. Now, you are dropping a massive point load of stone onto that exact same space.
But wait, why can't the builder just, add a few extra pieces of timber under the floor right then and there to hold it up?
Oh, they absolutely cannot do that. Builders cannot legally or safely guess structural engineering. They have to immediately halt work in that area.
Oh, wow.
Yeah, they have to call in the structural engineer to mathematically redesign the floor system to safely carry that new load path. That means reinforcing the joists, ordering new structural timber or bespoke steel beams, and that stuff takes days or weeks to arrive on site.
So the carpenters are just standing around. Or they have to completely demobilize and move to another part of the house, which just kills the momentum.
It completely derails the schedule. And that is just the weight of the tub. What about the plumbing?
Right, the drain.
The plumbing adds a whole other layer of complexity. Because the new custom tub has a different shape, the drain location is completely different. The plumbing, the pipes that have already been carefully laid out and installed, they no longer align with the new drain.
So they just move the pipe.
It's not that simple. Now we have to look at the interstitial space.
Interstitial space. I've heard that term used in biology, actually. But how does it apply to a house?
In construction, the interstitial space is the service zone, or the cavity between the major building layers. So, think of the hidden space between the floor you walk on and the ceiling of the room below it.
Ah, okay. Like where all the guts of the house live.
Exactly. It's a highly congested highway that houses the mechanical, electrical, and plumbing systems. The new drain pipe for this custom tub now has to navigate through an interstitial space that was meticulously designed for a completely different layout. And it might have to cross through structural beams that it simply wasn't supposed to cross.
And you definitely cannot just drill massive holes through structural floor joists to make room for a pipe.
You absolutely cannot, because if you compromise the joist, you compromise the load path again. Furthermore, the builder has to make sure that however they reroute this plumbing, it still complies strictly with the PCA.
The Plumbing Code of Australia.
The Plumbing Code of Australia, yes. The PCA mandates minimum technical requirements for drainage systems, specifically focusing on gravity and water flow.
Right, because water has to flow downhill.
Exactly. If the new pipe routing has to twist and turn around existing obstacles within that interstitial space, and it doesn't achieve the correct fall or downward gradient, it violates the PCA. It simply will not pass the mandatory council inspection.
This is staggering. So my casual weekend decision to upgrade my bathtub has halted construction, required a structural engineer to redesign the load path, forced the plumber to tear up the interstitial space, and risked a violation of the Plumbing Code of Australia.
And we haven't even touched the administrative side of the problem yet.
Oh, there's more.
Oh, yeah. Because the builder cannot proceed on an assumption, and they certainly cannot build something that violates code, they have to officially pause the work and issue an RFI.
A request for information.
An RFI, yes. It's a formal document seeking clarification when project details are missing, conflicting, or have been changed midstream. The builder sends this RFI to the architect and the engineer saying, the client changed the tub. The load path is compromised. The interstitial space is insufficient for the PCA drainage requirements. Please advise on the new structural and plumbing design.
So the builder just has to wait while the professionals go back to their desks.
They wait. The architect has to redraw the plans to accommodate the new footprint. The engineer has to calculate and approve the new load path. And once those new plans finally come back to the site, it triggers a variation.
A variation.
A variation is a formal change in the scope of works and the contract. It means the schedule is officially delayed, new materials must be ordered, and the carefully planned sequence of trades is entirely disrupted. The waterproofers cannot come in until the new plumbing is done and inspected.
Right.
The tilers cannot come in until the waterproofing is cured.
Let's zoom out and look at the emotional result here for everyone involved. What could have been a simple, easily adjustable line item on a piece of paper during the design phase has metastasized into this incredibly expensive, time-consuming crisis on the active construction site.
That is exactly the friction that Simpson & Co. projects is highlighting. When unresolved details hit the site, the project moves from being proactive to entirely reactive.
Yeah, that makes sense.
As the client, you are suddenly forced to make rushed decisions under immense pressure. You're paying for delays, the schedule slips, and honestly, most damaging of all, there is a severe breakdown in trust between you, the architect, and the builder.
I could totally see how that trust evaporates. From the client's perspective, it just feels like the builder is dragging their feet or being super difficult about a simple bathtub.
Exactly.
But from the builder's perspective, they are scrambling to safely integrate a massive structural change that was never accounted for in the original detailed documentation. They are taking on all the risk.
And the builder's experience on site in these moments is incredibly stressful. I mean, they're managing dozens of trades, strict safety regulations, and tight timelines. When they are constantly forced to stop work to resolve design gaps or unapproved changes, it leads to severe burnout.
Yeah, it sounds awful.
The friction does not come from the act of building. It comes from trying to design the building while you are actively constructing it.
Okay, so if the linear model is fundamentally broken because it relies on assumptions, and assumptions lead to this entire domino effect, it sounds like the only way to fix this is to break the timeline itself. How do we pull the builder out of the construction phase and inject them into the design phase?
Well, the solution that Simpson & Co. projects advocates for is entirely changing the sequence of the process. You have to abandon the siloed linear model.
Right.
The antidote is early, rigorous collaboration. You must bring the builder into the room alongside the architect during the design phase, long before the detailed documentation is finalized.
Going back to our movie analogy, you bring the special effects supervisor into the writer's room.
Exactly.
So when the writer says the city floats, the effects person can say, here's exactly how we can shoot that practically, and here's what it will cost logistically.
Yes. When the builder is in the room during the design phase, they engage in a really critical process called value engineering.
Value engineering.
Yeah.
Let's break down the mechanics of that. How exactly does a builder sit in a room with an architect and, challenge a design without stepping on toes or completely ruining the aesthetic vision?
Because value engineering is not about cheapening the design. That's a huge misconception. It is about reviewing the architectural vision through the lens of constructability.
Ah, okay.
The goal is to find more cost-effective, highly constructible ways to achieve the exact same aesthetic or functional result.
How does that look in practice, though? Give me an example.
Sure. Let's say the architect designs a massive cantilevered roofline. It looks stunning on the concept drawings, but the builder looks at the plans and applies their knowledge of live market conditions. The builder explains that to achieve that specific overhang with the current load path, they will need to crane in custom structural steel. That pushes the timeline out by widths and significantly increases the structural budget.
Right, which the client probably doesn't want.
Exactly. However, the builder suggests that if they adjust the overhang by just a few inches and introduce a subtle, hidden support column within the wall cavity, they can frame the entire structure using standard timber.
Oh, wow.
Right. To the naked eye, the aesthetic is identical, but mechanically, it changes the execution from a complex, high-risk steel job to a standard, predictable timber job.
So you are solving the physical problem cheaply on paper before a shovel even hits the ground.
By replacing assumptions with hard data, having the builder there ensures that the design perfectly aligns with the client's financial boundaries. And this is often facilitated through transparent pricing models, like cost-plus structures, rather than traditional fixed-price competitive tendering.
Wait, let's explore that. Because if I bring a builder in early and agree to a cost-plus contract, doesn't that just give them a blank check? I mean, how does a cost-plus structure actually create transparency and prevent the client from just getting completely gouged?
It's a really great question, and it is a very common misconception. Think about a traditional fixed-price tender. A builder has to guess the future costs of materials and labor, right?
Yeah, they have to predict the future.
So they naturally bake hidden margins and contingencies into their final number to protect themselves. It creates an inherently adversarial relationship. You're always wondering where they are making their money.
Right, you feel like they're hiding something.
But in a properly managed cost-plus structure, the pricing is entirely open book.
Meaning the client sees everything.
Everything. The client sees the raw invoices from the suppliers and the trades. The builder's margin, their fee for managing the project, is either a fixed percentage or a transparently agreed upon sum applied on top of those raw costs.
That's fascinating.
This fundamental shift aligns everyone's incentives. The builder is no longer trying to protect hidden margins. They become a consultant working actively alongside the architect to find the most efficient way to build the home.
It forces you to do the hard work up front. It forces those difficult, sometimes uncomfortable conversations about budget, materials, and structural reality to happen in the boardroom.
Rather than screaming over the noise of a concrete mixer on a Tuesday morning.
Exactly. It replaces the anxiety of the unknown with this rigid, systemized framework of absolute clarity. When you know every detail has been resolved, and you understand the true cost of every component before construction begins, the actual building phase becomes what it should be.
An exciting process of execution.
I think that is the ultimate takeaway here for anyone listening, regardless of your specific field. Whether you are building a custom home, launching a new software product, or, I don't know, planning a massive corporate overhaul, isolating your designers from your builders is just a guaranteed recipe for stress.
It really is.
When the visionaries and the executioners don't communicate until the very last minute, you are simply building a project out of assumptions.
And assumptions inevitably collapse when they meet the friction of reality. If we connect this to the bigger picture of your own life and work, I really want to leave you with a question to mull over.
Let's hear it.
Think about a current project you are spearheading right now. Are you operating under comfortable assumptions that are going to surface as expensive, time-consuming crises later down the line? Who is the builder in your professional life, the person who actually has to execute your vision on the ground that you need to bring into the room today?
Click the link in the YouTube profile description to read the full article directly on the Simpson & Co. Project's website.